Greetings from my recording studio located in a yurt at the base of Maroon Bells near Aspen, Colorado. And welcome to this presentation on an ancient solution to quadratic equations. This is a visual presentation based on earlier work of some really excellent presenters on this topic. You'll see their YouTube channels listed at the end of this presentation. So exactly what is a quadratic equation? If we look at a quad, like this, with sides x minus 2 and x minus 12, we can multiply those sides like we did here. Once we do all of the required multiplication, an expanded form of that looks like that. Then we can combine similar terms like this to get 14x there, and the product of these two gives us the 24. This representation on the left is a specific equation. But if we take non-numerical forms of the sides of that quad and multiply them, we end up with something like this. The critical point in looking at these equations is that this term here is the sum of x1 and x2, while this term is the product of x1 and x2. At the end of the day, what we're really looking for whenever we have a specific equation is to determine the values of x1 and x2. And specifically, we want values of x1 and x2 that give us these points here. These are called the zeros of the equation because they're located on the x-axis, where the output value or the y value equals 0. Typically, we'd write the equation as x squared minus, in our case, I think it's 14x plus 24, and we would set that equation equal to 0. Now, if we would graph a lot of equations like this and then draw a vertical line through the vertex, and if we study it carefully, we'll notice a couple of things that are important to us in this development. One is that this point here and this point here are an equal distance from that line that we drew through the vertex. In fact, every point to the right of that line that lies on the graph is exactly the same distance as every point on the left-hand side of that line is from that line of symmetry. Now, I just introduced a new word. This is called the line of symmetry. Because the graph is symmetric left and right about that line. So we notice that the line is symmetry is halfway between this point and this point. Whenever you have 2 points on a line, vertical or horizontal, it's easy to determine the midpoint. You simply take the end points. In this case, pardon me, we have 2 and 12. We add those together. We average those, and we're going to get 7. The important thing to notice here is that whenever we add the 2 and 12, the endpoints of this line on the x-axis, it comes out to be 14. And if we follow this yellow line up to here, we'll see that the x term in this equation is at 14. The important point here is that that's always the case, and that if you know what that x term is, all you have to do is to divide that term, 14 in this case, divide by 2 equals 7. And you'll see that this line of symmetry passes through x equals 7. In general, the midpoint or the location of the vertex is simply x1 plus x2 divided by 2. We won't always know what x1 and x2 is going into the problem. That's what we're going to want to determine. Let's see how this works. In this graph, I've shown that these points lie 5 units to the left and to the right of 7. Since we are wanting to determine x1 and x2, we want to determine those particular points, we need to write an equation that relates each of those points to the midpoint and the distance that those points lie from the midpoint or the vertex, the line of symmetry. So for this particular equation, these are those equations. Now let's suppose that we're given an equation and we don't really know yet what this point is or what this point is. We can write a general equation for each of those 2 points that we're trying to determine. So in this case, x1 is over here, and we subtract this distance u from that midpoint, from the line of symmetry over to x1, and that's 7 subtract u equals x1. Likewise, on the other side, it's going to be 7 plus some unknown distance equals x2. So we have related these points that we're looking for to the midpoint or the line of symmetry and the distance that these points lie from the line of symmetry. In this slide, I've removed all of the information on the graph. We just represented this point and this point as x1 and x2. Remember that this is our equation, and from our previous discussion, we know that the vertex or the halfway point is located at x equals 14 divided by 2. In that case, that's going to be this line here, and that point right there is x equals 7. Which I've drawn here. Now, knowing that x1 and x2 are the same distance from the midpoint, we can now write expressions for x1 and x2 that are related to this point and to this unknown distance that we see here. Those equations that represent x1 and x2 as related to the line of symmetry and the distance from the line of symmetry are given here. From the second slide in this presentation, we know that x1 times x2 equals 24. But now we have other expressions for x1 and x2, and we'll put into this equation. Here we have x1 times x2. Here are the expressions that we develop for those. We know it equals 24. So whenever we do this step here, we'll wind up with an equation with a single unknown, where in this equation, x1 and x2 are both unknown. This eliminates those unknowns and gives us an equation that's going to be easy for us to solve because it only has one unknown value. We go through the math, You can follow it through all the way down like this. In this step right here, we're going to subtract that u squared term, we're going to add u squared term to both sides to get this equation. We'll subtract 24 from both sides to isolate that squared letter. Gives us this. And finally, when we get down here, we take the square root of both sides and we get u equals 5 that we see here. And that's what we had seen before. No great mystery, but you can do this with any quadratic equation. This procedure right here. So now we have u, and we know that u is the distance between the line of symmetry and the points on the x-axis that we're looking for. And we have these two equations that relate x1 and x2. Those are the points on the x-axis for which we're looking. We know the value of u, and all we have to do is place that value of u into those equations and solve, and we get x1 equals 2 and x2 equals 12, just as we expected. Let's compare that now to the quadratic formula, which you're all familiar with. Typically written like this. I'll almost always write it like this, because in this form, that minus b over 2a is a coordinate of the midpoint or the vertex. We saw that was 7 in our previous one. And then this term, the square root of b squared minus 4ac over 2a, is the distance left and right of the x-coordinate of the vertex. That pretty much wraps up this presentation. I would like to give due credit to a couple of really, really good presenters. Here are the URLs for their presentations in YouTube. Highly recommend that you go watch those. So at the end of the day, there's only one thing left to say, and that is that's all, folks. Thanks for watching. Thanks for learning. Stay safe. Con cuidado.